If you've watched my earlier lessons on stoichiometry, you might remember this stoichiometry island diagram. And you can see that what I've done here is I've modified it slightly such that it now takes into account molarity. Previously, it had the three circular islands on each side and then the triangular mole island. Well, now we've added the molarity and the liters component to it so that it applies for solution stoichiometry. So let's try this problem. What volume of 0.150 molar sulfuric acid is needed to neutralize 26 grams of sodium hydroxide? So sulfuric acid, we know, has that chemical formula. Sodium hydroxide has that chemical formula. And we should recognize that any time we have an acid reacting with a base, we're going to get a salt and water. And the formula of the salt will consist of the cations from the base, and the anion will come from the acid. Na2SO4, sodium sulfate is the name of that compound, and of course water. Then we want to balance this like so. Okay, from the problem we can see that we are going to have to calculate something that's related to sulfuric acid. In previous lessons, the way I teach this is the islands on the right represent the substance that we are trying to calculate something for. The islands on the left represent the islands where we know the amount. And clearly we know the amount of sodium hydroxide, 26 grams. So we're going to start some calculating up here in the upper left. Now, if we look over here on the far right, volume and H2SO4, we might be tempted to go to this island right here, volume. But you might recall that that island is for volume of gases and specifically at STP. That's because this conversion factor bridge right here goes something like 1 mole of any gas at STP equals 22.4 liters of volume. But sulfuric acid is a solution. It's a liquidy-like thing. So where we're actually going to end up is not volume island over here on the far right, but volume right there. That's related to the concentration of the solution. So here's what we're going to do. On this diagram you can see we're going to start in the upper left at mass of sodium hydroxide. We're going to go one conversion factor to moles of sodium hydroxide, another conversion factor to moles of sulfuric acid, and then we're going to use the molarity relation to calculate volume of sulfuric acid. So let's do that. 26 grams of sodium hydroxide. We need to use the molar mass to convert into moles of sodium hydroxide. In the lower right here, I've pulled the appropriate information from the periodic table. 23 plus 16 plus 1 gives us 40 grams of sodium hydroxide. Grams of sodium hydroxide. So now let's cross the middle bridge. We recall that when we cross the middle bridge, we need to use the coefficients in the balanced equation. And that's going to give us 0.325 moles of H2SO4. So now what we know is the number of moles of H2SO4, and our problem tells us the molarity, 0.15 molar. Liters is moles divided by molarity. There the number of moles, there's the molarity, 2.2 liters. Let's try another one. What mass of lead 2 nitrate will consume 85.0 milliliters of 0.45 molar sodium iodide? We should recognize this as a double replacement reaction, where the ions switch partners. We're going to get a lead 2 iodide precipitate, and then we're going to also get some sodium nitrate, which you probably remember from our solubility mnemonics. Both of those products are touched by the solubility mnemonics. Sodium nitrate is soluble. It's not all that relevant for this problem, but anyway. So let's balance the equation by putting coefficients of 2. And what we're going to see here is that the left side of our island diagram represents sodium iodide, and the right side is lead 2 nitrate, because we are going to calculate mass of lead 2 nitrate. So we want to end up in the upper right corner here. As it stands, we are given the molarity and the liters of sodium iodide. We're given these two quantities, so here's what we're going to do. We're going to use the molarity relation to calculate moles of sodium iodide, which is right there. Then we're going to cross that middle bridge, then we're going to go up, and we'll have calculated the mass of lead 2 nitrate. Moles of sodium iodide is molarity times liters. Notice that milliliters is not okay in calculating moles. We need to change milliliters into liters, so I've done that here, 0.085 liters. So we have the moles of sodium iodide. We're now going to cross the middle bridge and then go up and to the right, and we'll be done. 0.03825 moles of sodium iodide. We're going to cross the middle bridge using the coefficients in our balanced equation. Cancel the units. And now we need to convert between moles of lead 2 nitrate to grams. So we need to consult the periodic table such that we can calculate the molar mass of lead 2 nitrate. 1 lead, 2 nitrogens, and a total of 6 oxygens. Check it out, it adds up to about 331.2 grams.